Hello and welcome back to another Calculus 3 multivariable calculus video. Today we are going to be going over 3D graphs. So jumping right into it, we kind of just have to ask ourselves, why do we care about 3D graphs? Well, essentially when we are looking at functions in 3 dimensions, we need to understand exactly what that domain underneath that function is. So essentially why we care about 3D graphs is because we want to know what the domain of our function is. And going along with domain, we also want to understand what our range is. Although that is not something that you will be asked about very frequently within this class. Certainly not something I think you'll be tested on, but it's just good to know what your range is given that domain. And we also just want to be able to graph our XYZ function. So I guess the how for how we're going to do these 3D graphs is we are going to look at considerations. Considerations is in we are going to essentially solve for our domain given a function, okay? So our main concerns, firstly, we are worried about square root of x, or square root of something, square root of some function of x, because intuitively you understand by now that you cannot square root something that is less than 0. Therefore, we have to have x is less than or greater than or equal to 0. So that's one of our main concerns. So the how, like I said prior, is we are essentially going to have that, our f of x, y, perhaps z, is going to be less than or equal to 0 when it is in a square root. Second concern that we may have is the natural log. Natural log of x, wherein you cannot take the natural log of anything that is less than or equal to 0. Therefore, we have to have an x always greater than 0. So in this situation, we would have to have our how being our f of xy, once again, perhaps z, must be greater than 0. And of course, division by 0. We know by now that you cannot divide by 0. So that is another consideration that we are going to want to take into account. So using these notations, we are going to essentially have a set builder notation in which it represents our domain and our range in some scenarios. I will not be covering range, but it is something that you should definitely keep in your mind. So I guess the best way to do this is to just go into an example wherein we look at our first consideration, our first main concern, which is the square root of something. So let's just say we have some value, z is equal to the square root of 4 minus x squared minus y squared. We want to find domain. So like I said, in order to do this, we essentially have this function within the square root here. And as we stated prior, this function needs to be greater than or equal to 0. So this is just going to be our f of xy. So therefore, we have, in other words, z is equal to the square root of f of xy. Once again, this f of xy must be greater than or equal to 0, otherwise it is no solution. Therefore, let's just go ahead and plug in our function there. So we have 4 minus x squared minus y squared has to be greater than or equal to 0. We can just go ahead and do some simple algebra here. We have 4 must be greater than or equal to x squared plus y squared. So this gives us our set builder notation that we are going to need. So then this is just going to be our domain, essentially. This works, but we want to have it in set builder notation. So we are going to just make the set of x, y, such that the x squared plus y squared is less than or equal to 0, or 4, sorry. So that is our domain. And the neat thing that we can do here is we can essentially graph this on an xy plane, and that will essentially tell us, and it's easier to visualize it in an xy plane, so let's just go ahead and graph it. Here's our xy. We're actually going to extend it out a little bit more. Fix it up a little bit. Okay. So, x squared plus y squared has to be less than or equal to 4. Well, let's think about what that means. X squared plus y squared, we all know that is the equation of a circle, and that 4 is going to be the radius of our circle, okay? So that is the diameter, I apologize. The diameter of our circle, meaning that the radius of our circle is just going to be 2. So I'm going to scale this up a little bit. So this is going to be 2. 1, 2, 3, 4 is going to be 2. 2, 3, 4 is going to be 2. 1, 2, 3. A little bit short. It's okay. So drawing the circle that we have from our set builder notation is going to look like that. And that less than or equal to 4, meaning what? This means that our x squared plus y squared domain must be within this circle. This is our domain. Meaning this is what our domain is. Easier to visualize in the xy plane. And when we translate it into 3 dimensions, this is going to be apparent. Let's do another example using our second concern. So, we are asked to find the domain of similar function z is equal to the natural log of 9 minus x squared minus y squared. So, similar process as the last time. We look over here at what our main concern is. Well, natural log of x has to be greater than 0. Cannot be equal to 0, cannot be less than 0, x has to be greater than 0. So, we have this function, f of xy, in which this needs to be greater than 0. So, let's come over here. We have 9 minus x squared minus y squared must be greater than 0, otherwise it is undefined. So let's just go ahead and do the same algebra that we did in the last one. We have 9 is greater than x squared minus y squared plus y squared. We can just go ahead and turn this into our set builder notation again. Let's go ahead and do that in the other color again. We have the set of xy such that x squared plus y squared must be less than 9. Otherwise, our function is undefined. So, if we come over here and graph it again, we have our xy plane here. Same thing as last time, x squared plus y squared is less than 9. Defines the circle with a radius of 9. So this one, I'm not going to scale it up. That should be okay. This is going to be our domain. So I guess the question is, what is the difference between the domain of our square root function that we had last time and the domain of this natural log function that we had this time? Essentially, the difference is that less than or equal to sign. Therefore, the domain includes this radius right here, the exterior of this circle, Whereas on this natural log function, it does not include the exterior of this circle, making it only within that circle is the domain defined. So essentially what this is it's an open boundary. Okay, so the square root is closed, whereas the domain for this one is open. That is essentially 3D graphs. We are just making the domain into the XY plane so that it is easier to visualize, and this is going to take us into our next topic, level curves. Level curves is also going to make these three-dimensional functions easier to conceptualize as well as visualize. Yeah, so that's 3D graphs. Thank you.